Hello everyone, my name is James Smith. I'm an electrical engineering major at FIU, and I'm here to talk to you today about the need to embrace accelerated bridge construction. What if I were to tell you that on your drive home today there's a 1 in 4 chance that the bridge you were driving on is structurally deficient? It's a scary thought, isn't it? It's terrifying. That's the case here in America. Of the approximately 600,000 bridges in the United States, approximately 1 in 4 are structurally deficient. Let that sink in for a minute. Let's talk about the problem. Of those 600,000 bridges spanning 20 feet or greater in the United States, approximately 9% or 54,000 are structurally deficient, and approximately 14% or 84,000 are structurally obsolete. What do we mean? Some of these structural deficiencies, so that 54,000 number, that includes issues such as cracks in concrete girders, corrosion of steel girders, pier cracking, other structural deterioration according to ACNOC. Structural obsolescence includes issues such as bridges not being reasonably serviceable due to misalignment issues, geometric issues that cause an increase in collisions, as well as lanes that are too narrow, according to ACNOC. So why accelerated bridge construction? Well, America's bridges are in terrible shape, and we've gotten here through traditional construction means. So why continue down that path? Accelerated bridge construction, also known as ABC, is faster, the components are of a higher quality, and overall, it is economically superior. If we switch to ABC now, we can actually start to reverse the problems that traditional construction has gotten us into. So traditional construction methods have gotten us to this point. Why is ABC the better option? Let's get into the specifics. ABC is faster. According to the FHA, total bridge replacement can be achieved in as little as 48 to 72 hours. 2 to 3 days, a bridge can be completely replaced. It's astonishing, isn't it? Absolutely astonishing. Think about how many months or years the last bridge construction project you saw took. In cases where existing components can be reused, that time can be shortened even more. For instance, bridge foundations can be strengthened and improved, safely support a new bridge that will be constructed using ABC methods, according to Davis, Kuman, Argawal, Sana'i, and Jones. Who cares how fast it is if it's not safe? But ABC methods are significantly safer. Let me tell you why. ABC methods allow for higher quality components rather than your bridge components being cast, your concrete being cast, and your steel sitting out for years potentially in the ice and the rain and the elements. ABC components are constructed in climate-controlled off-site locations, according to Colmo. One of the issues is concrete restraint. That's where you have an existing piece of dried, set concrete. You pour next to it because you want it to be a continuous run of concrete. And as the new concrete pour contracts, because it dries, since concrete has a water content, as it tries to contract, it can't, because it's now attached itself to the concrete, the solid structure around it, cracks form. This is a major issue. As you can see in that photo, cracks in bridges are hardly anything any of us want to see. Beyond the quality of the components and structural integrity of the components, we also have to consider roadway construction workers are killed all across America every single year. By reducing the amount of time that we have these construction crews on site by using ABC methods, we can immediately reduce the number of fatalities that we have in the United States per year. That's outstanding. Finally, ABC is economically superior. Now, here is the main issue, and the reason that we're not seeing ABC implemented nationwide in every city, state, highway, everything. ABC costs more up front. However, according to Bridgemaster staff, the FHA has reported that the costs to communities, the overall costs of having bridges shut down and the construction that goes with it, can actually cost more than the total cost of the construction project. The residual effects have a greater negative economic impact than the cost of the bridge. Why would we not transition to ABC and fix that? So what would the transition to ABC methods actually mean for us? The nitty-gritty, what does that do for us? What does that do for you? It's faster. The materials being constructed off-site are of a higher quality. They're safer. Overall, economically, we're in better shape. Every single thing about this is superior. We have 150,000 bridges in the United States that are in a state of disrepair. Those are bridges that our families and our friends, our loved ones, and even total strangers, of course they still matter, 150,000 across the nation that need repaired or replaced. My God, could you imagine what would happen if the Golden Gate Bridge were to collapse? All of the families and all of the lives negatively affected. You know the facts. There are 150,000 bridges in the United States in need of repair or replacement. There's an outdated system that has gotten us to this point that cannot fix it. And there is a solution in ABC if we transition now and if we implement it across the board as the standard for bridge construction from here on out. So what can you do? Why am I talking to you? Contact your local elected officials, contact your state elected officials, and talk to them about the need to implement ABC across the board. We would never want to see a bridge collapse like the 35 West in Minneapolis ever again. And maybe if we can start correcting the problems today, we'll never have to. I implore you, take action today. Thank you so much for your time. It's been a pleasure speaking with everyone. I'll be around the conference the rest of the day. If you want to sit down and chit-chat more about this, please feel free to let me know. Everyone, it's been nice meeting you. Have a great day.